Okay, now we're going to get into some of the big matrices stuff. So we're going to talk about finding an inverse with a 2x2 matrix. Now, I showed you two different ways to do this. I'm going to show you the first way first, and then later on in the packet, there's one that I can show you the other way. So if you're going to find it without using the determinants, remember, you're going to, I just don't feel like rewriting. So you're going to draw like this line, and on the other side, you're going to write the identity matrix. So now you basically have like this 2x4. Okay, so you have 2 rows, but now you have 4 columns. And so your goal is to get this left side of the line to be the identity matrix. So you're thinking, how can I break things down to get it to be the identity matrix? Now, when you're doing this diagonal, don't really worry about that diagonal. You're really worried about getting these to be 0. That's your goal. If you can get those to be 0, we can always multiply by a scalar at the end to create that to be 1. So you can work in any order. In this case, making this one a 0 first would be our easiest step, because I can just add row 1 plus row 2 to give me my new R1. Okay, so when I do that, when I add these two together, this is going to become -6, 0. Add this together, that stays 1, and this becomes 1. Okay? This row doesn't change at all because we were not doing an operation to change that row. Okay, so R1 plus R2, that became your new one. So -2 plus -4, -6. -4 plus 4 is 0. 0 plus 1, 1. 1 plus 0, 1. And then the second row stayed the same. So now we're going to try to zero out this one right here. So to zero out this one, I'm going to think, okay, if I do R1, and I add R1, and then I need this to be a +6, so plus -3 R2, like that. I'm going to write the actual row operation this time because it wasn't quite as simple as the one before. So -6, 0, 1, 1. We didn't change that one. And then we multiplied this whole row by -3. So this became +6. This became +12. This stayed 0, and this became -3. Add those together. This becomes 0, 12, 1, and -2. That's going to become our new R2. All right, so I'm going to come down here. I'm going to write what I have. So R1 stayed the same. R2 became 0, 12, 1, -2. All right, last step is you have to create these to be 1s, okay? So again, your easiest step at this point is going to be to multiply by a scalar to bring them down to be what you want them to be. So if you multiply the whole first row by -1/6, -1/6 times -6 is going to give you a +1. So you're going to get a +1. -1/6 times 0 is still 0. -1/6 times 1 is -1/6, -1/6. This row stayed the same. And now again, our last step is to get this to be 1. So now we're going to multiply by 1/12 by R2. And this is going to stay the same. -1 or 1/12 times 0 is still 0. 1/12 times 12 is 1. 1/12 times 1 is 1/12. And 1/12 times -2, that's going to give you -2 over 12, which is going to reduce to -1/6. Now that I've gotten the identity matrix on this side, my inverse is what happened on this side. So let's say that this was A, that was matrix A. that means that the inverse of A is equal to -1/6, -1/6, 1/12, and -1/6. Again, you can do this in the calculator. So if this is given to you on a calculator portion, knock it out in the calculator. So you're just going to type in your matrix in this case. So this was a 2 by 2, and it was -4, +4, -4, -2. And you're going to come out here and you're going to raise it. So that button, raise it to the -1 power, and it's going to pop back out. -1/6, -1/6, 1/12, -1/6. Again, if you wanted to check yourself, if you multiply your inverse times your original, you should get your identity matrix, and that's always a great check too. So if I came down here and I multiplied this times my original, which was -4, +4, -2, -4, you can see how you get the identity matrix, and that's what I was talking about earlier for that conceptual stuff. Okay, next thing is we are going to find the determinants. So determinants of a 2 by 2 are pretty straightforward. So it's going to be, you're going to take this diagonal minus this diagonal. So this diagonal, 6 times 0 is 0, minus -18, which is going to turn into addition, which is just going to give you +18. So your determinant is 18. This one, you're going to take this minus this. So -4 minus 30, because it's always multiplication. So this is going to give us -34. This, again, is something that you can do in the calculator. This one is a command, so you need to start by putting in your command. So menu 7, you want to find the determinant, which is 3, and you'll get that it says DET, and then you can type in your matrix. So this one was 6, 3, 0, up, -6, 18. If you did the other one, menu 7, 3, you're going to type in, let's move a little, -1, +5, 4, +6, enter, -34. Okay, so if that comes up on the calculator, you can do that too. Last thing we're going to talk about on this page, explain the significance of a determinant of a matrix being equal to 0. Okay, I am sure that this is going to come up at some point on your test. I don't know to what capacity, but I'm sure it will. So if you ever get your determinant to equal 0, that means that the matrix is not invertible. Okay, that means an inverse does not exist. So if you ever figure out the determinant and you got 0 instead of -34, and then they asked you to find the inverse for that matrix, you can't. You're done, because there's no inverse if your determinant's equal to 0. All right, hop on to the next one. If you guys need some more help, we're rocking and rolling.